Example number 2, highlighting learning targets number 1.5b and 1.5c. It asks to represent the data or the table of two quantitative data plots. So we have two quantitative data plots, one being the minutes of studying, the other being the exam score. So we're going to represent these two data plots on a coordinate plane and then interpret the shape, center, and spread, accounting for possible effects of extreme data points or outliers. So what we need to do, first of all, is we need to determine which is the X or input or independent variable and which is going to be our dependent. Well, to begin, which one can we control? Well, we can really control our minutes of studying. So this is going to be our independent variable. So this is our independent variable, which we represent with X. Now, logically, if you think the minutes that we spend studying will affect our exam score. So you would think the more you study, more than likely, the better exam score that you would get. And so our minutes of studying would affect our exam score. So what I want to do, I just noticed, I want to color coordinate these a little differently. I'm going to write this one. This is our independent variable, which we represent with an X. And this is the dependent, because our exam score will depend on how much we study, and we represent our dependent variable with a Y. So now you may recognize that we have an ordered pair. So our ordered pairs that we can now write are going to be 0 for our minutes of studying. And what score would you have estimate that you would get if you studied 0? Well, you would estimate that you would get a 40%. If we were to look at if we studied 15 minutes, our estimated score would be 55. If we were to study for 30 minutes, our estimated score would be a 70%. If we were to study for 45 minutes, our estimated score would be an 85%. And then lastly, if we were to study for a full 60 minutes or 1 hour, we would estimate that our exam score would be a 100%. Now you may recognize these as ordered pairs, but these ordered pairs are showing the relationship, again, a relationship between the minute studying and an exam score. And as you might recall, we represent or best represent data that shows relationships on a scatter plot. So the most appropriate type of graph would be a scatter plot. So let's plot these on a coordinate plane as these ordered pairs as a scatter plot on a coordinate plane. So looking at a coordinate plane, we have our origin. Now one thing that we have to realize is that these points are a little larger than 0, 1, 2, 3, 4, 5. So we're going to have to change our scale, and that's okay. So our scale is going to be by 15. So we have 15, 30, 45, and 60. Actually, let's look. Is that, let me double check. So 0 minutes of studying and 15, that is correct. Okay, so our x-axis, again, is our independent variable. And so we are going to have, I'm going to write it this way. It's a little bit easier to see. So 15, 30, 45, and 60. Those are our minutes of studying. And better yet, I'm going to color coordinate them in green so that it is 15, 30, 45, and 60. And if we look at our exam scores begin at 40 and go to 100. So I have to have a relatively large range, and I've got, so if I go by tens, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, that'll work. So I can have a 10, 20, and I'm going to have to write it a little smaller, I believe. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So now I'm going to plot these points. So if I studied for 0 minutes, I would get a 40. Well, where is 0? Well, 0 starts at the origin. I don't go anywhere on the x-axis, and I would only get a 40%. So there is 0, 40. If I study for 15 minutes, I estimate that I would get a score of 55. So I'll go to the 15, and then I go up to 50, and it's halfway between the 50 and the 60, so it would be 55. If I study for 30 minutes, I estimate that I would get a 70, so go over to the 30 and then up to the 70. When I look at the 45, I would estimate that I would get an 85, so that would be here. And then lastly, if I were to study for 60 minutes or a full hour, I estimate that I would score a 100%. So I've plotted the data and I've represented the relationship between the two quantities, but I have yet to distinguish them by or interpret them based on shape, center, and spread. Well, when I talk about shape, center, and spread, what I'm referring to is the correlation. And so when I look at this, I notice, okay, first of all, are they correlated? Well, it looks like they are. It doesn't look like chickenpox. So it does look like the data is correlated. And so it looks like that there is a correlation. In what direction is this actually moving? Well, it's moving in the upward direction. And so I can remember that data that moves in the upward direction is positive. So we have a positive correlation. Okay, so we have shape, center, and spread. And so we know that the shape is a positive with a correlation. And so now we have to think about the spread. And the spread is referring to outliers. Are there any outliers? Now, what an outlier is a data point that doesn't really match the rest of the set. And an analogy or an example could be if I were to choose 5 random students from the class and we were to go on the basketball court and form a basketball team. They would have an average skill level of basketball. And we could plot their skill levels and they would be relatively close, not too far apart. But then if I were to invite LeBron James to come in and join our team, and then I were to plot his skill level, what do you think might happen? Well, it would completely skew the data. It would throw the data entirely out of balance because his skill level is so much beyond any other players on the team and probably within the school that it wouldn't really match the rest of the data. He would be considered an outlier, not a real representative of the data that we are actually representing. And so what we need to look at, is there anything that is not within this data set that would be considered an outlier? Is there anything in that data set? And so what that might look like on a graph is if I had a data point that was maybe way over down here somewhere. Doesn't really match. It doesn't go with the rest of the data. Or if I were to have a data point that was somewhere down here. These data points do not represent the rest of the data in the same manner. So we would call those outliers. However, in this case, we can notice that all of this data is relatively tight in spread. There is not a lot of variation in it. And we know that it's positively correlated, and they relatively are uniform as far as how they are in relation to each other. So in this case, we would conclude that there are no outliers. So there are no outliers in this case. So we have positively correlated data with no outliers. And what this tells us, if we were to come to a conclusion and interpret this, what this would tell us is that as we increase hours of study, there is an increase in exam scores. And so that is our interpretation based on center, shape, and spread, representing the data, again, best on a scatter plot because we are wanting to highlight the relationship between the two data points or two quantitative data sets.